Hi class, good evening. This is Professor Jain. I had a little fender bender on my knee, so that's why I'm recording this class from you from home. So before we move on, the exercise that was scheduled for today, um, we won't be doing that. Instead, I'm asking you to take a look at this presentation that you have here. And this in essence becomes your lecture. And I will have question of the day built into this presentation that I'll ask you to do and send that to me as a document before Thursday, and that'll be what I'll be requiring you to. So this session is divided into essentially four different pieces of 15 minutes each, and I'll have a review at the end of each 15 minutes, and then we'll go from there. So let's get going on the topic for today. We talked about process charts last time. I think we talked about how a process chart can be used to document all the activities that are performed by a person or a group. Now, as I had talked about before, this is kind of a review, but these activities are typically organized into five categories. You have operation, which is denoted by a circle, and then you have the transportation, which is denoted by a arrow, and then you have inspection, which is essentially denoted by a square, and delay denoted by a symbol D, which is filled in the middle, and then you have storage, which is denoted by a inverted triangle. Now, many of these activities can fall into value-added and non-value-added activities. As I had talked about here, operation and transportation essentially are your value-added activities. On the other hand, you talk about inspection, delay, storage, or staging. They can sometimes be referred to as non-value added activities, and you would like to reduce your non-value added activities. So we talked about this example in which you had a process chart for getting a person into an emergency room, and then there's the steps that kind of fill out on the step description, and then there's the cross for each of the activities that is happening on each one, and then here's the time and the distance for each of these activities that you see on the chart. And then here's a summary of all the different activities in which you have operation, which has 5 steps, takes about 23 minutes, transportation is 9, 11 minutes, and so on. And as you can see, that inspect and delay, which are supposed to be the non-value added activities, take up a significant amount of time, but at the same time, they don't add any value to it. So this can be a beginning step or a beginning kind of a process analysis to see if the inspect and the delay can be reduced in any way. All right, moving on. The process charts, there's a cost analysis side to it as well. As you can see that the annual cost of an entire process can be estimated. So you can see that how many hours was taken to perform each process, what was the variable cost for each hour that the process was done, and the number of times the process is performed each year. And that gives you the annual labor cost for that specific process. So here's an example. For example, if the average time to serve a customer is 4 hours, the variable cost is 25 per hour for the person who is the customer service representative, and then you have 44 customers that are served. So the total labor cost is the 4 hours for a customer multiplied by 25 hours for the labor cost, and then the 40 customers a year. So the total cost is $4,000. All right, moving on. So that was an example. Now there's some work measurement techniques. These techniques can be used to do many different things. For example, in a factory, this can be used to measure how long did a specific process take, or how long was a worker waiting to get a process done. In a warehouse situation, it could be how long did it take for the pallet to be put away from the time it came on the dock door to the time it was put away on a shelving, on a pallet shelving somewhere in the warehouse. In a terminal, which is a transportation terminal, and you're talking about a container terminal, how long did it take for the container to be offloaded from the ship or the container ship to the dock, and then from the dock to the drayage area where it's being staged for the time being. So those are some metrics to measure how long it takes for a specific job to be done. And that specific activity of measuring the time is known as the time study method, which is the first on the list. The the other process or the other approach is an elemental standard data approach, in which essentially what happens is you go by how long it took to do a standard job, um, and then you change that every time a person does a job. So, for example, in the first year, there were 6 people that were hired, and they took maybe 10 minutes to do a specific job. And then 6 months afterwards, they hired more people on, and these people were more experienced and they knew how to get things done. They probably took like 6, 7 to 8 minutes. So it's different, and then the standard changes depending on who is doing that. Now, you can have a predetermined data approach in which you find out the average for the last 6, 7, 10 years, and then you put that as a standard. And then it doesn't matter if somebody is doing better or worse, and you go with that. The other is work sampling, in which essentially the work is sampled at regular intervals, and that is how the standard is set. Now, we talked about learning curve. You remember how the other day you were making the airplanes, and then the airplanes sometimes you could make really fast, and then sometimes the first time you were making it was really slow. So the second time when a person was making the airplane, they became much more adept at making the airplane because they learned the steps. And that is what is known as a learning curve. So the more a process is repeated or more a process um, is done over and over again, a person doing the process becomes better and better progressively. But there's a diminishing curve to this learning curve in the sense that once you go from the first to the second one, you see a significant drop in the time that it takes to do the first to the second step. And then you go from the second to the third unit, it may take a lower amount of time, but it's not as significant as a drop from the first to the second one. So there's a diminishing attribute to a learning curve. As you produce more units, you get better, but then the more units you produce, you learn less because your chances of learning more are diminished. So here's an example in which there's a watchmaking assembly plant in which a process has been changed. So the time standard for the process was 14 and a half minutes, and now based on the new time study, should the time standard be revised? So the new time study had an initial sample of 4 observations, and I'll show that to you in the next slide. The performance rating factor is shown for each element, and the launch for the whole process is 80% of the total time. So the total time that you get, you multiply it by, um, excuse me, 1.18 to get 18% of the launch. Let's look at how the data on this one looks like. So you have element one, and you have 4 observations for that. Um, okay, so as you can see, you have element one, which is this right here, has 4 observations. And then as you go on to the other one, you have element two, which has certain observations, and then you have element three, which has certain observations, and then you can see the average for 3 elements is taken here, and then here's the rating factor, and then this RF is multiplied by 2.73, and that gives you 2.73, and then so on, and this is added up. The normal time is added up, and what you see here is the total of the normal time is about 10 seconds. Now this 10 seconds you can see is being multiplied here by 1.18 down here, and that gives you 11.82 minutes for every watch, and that is the new time standard. Some more data analysis tools that you can find out there um, to essentially measure how a process is being. These can help you identify causes of problems. For example, the first one is a checklist. I'll talk about each one as we go down the list, and then show you some examples. They have a checklist. You can have a histogram and a bar chart. You can have a Pareto chart. You can have a scatter diagram. You can have a cause and effect diagram, and you can have graphs. Now, all of these are data collection tools. What they do is they take the data and then they display the data in certain ways. And the whole point of collecting this data is to find what are some areas which can be used to analyze the problems. For example, you have a person that is checking passengers to get on an airplane in an airport. Now, what are some ways that a person can get delayed during the check-in process at an airport terminal? So they can have a mutilated pass, they don't have a pass, or they had a pass and it was lost. Um, you can have passengers who are on the wrong gate in a terminal where they shouldn't be, and so they're the wrong terminal gate. And then you can have problems, for example, the plane didn't arrive on time. That can be a problem to get the passengers out on time. You can think about the luggage which is supposed to go on the airplane and there was nobody to load that luggage into that airplane. That can be a problem. So those are all problems, and now what you're trying to do is which one of those is the most significant problem that you're trying to rectify so that you can expedite or you can fasten the process of getting passengers on this airplane. And now that's your data. So you collect the data on the different problems, and now you have different ways and means of showing that data. And what you see here, the 6 tools that you're looking on the screen here, they essentially help you to um, display that data. So let's take a look at some of the more specific things on that um, tool. So let's see, the first one is a Pareto chart for a restaurant. So in this Pareto chart, um, so the manager of a neighborhood restaurant essentially is concerned about the smaller number of customers patronizing his eatery, and then he is thinking that complaints have been rising for his restaurant, and he would like to find out what are the problems and how can he address those problems so that he can get more customers back, and then he can explain it to his employees that what's the problems and here's what you need to fix. So the solution is the manager surveys his customers over several weeks. So whenever a customer came in, he essentially had a survey form saying if you fill this out, we'll give you free entree or a free snack or a free starter item when you come in next time. So the customers took this person up on their offer to get feedback, and this is what he found. So this courteous server was 12 times, he had slow service 42 times, he had cold dinner, and so on. And now this person wants to find out that how can this data be lined up to show the data. So here's what he did was he found out that how many failures were for each problem. You see his discourteous server was the medium 10, 11 points. He had slow service, which has had the most significant piece of it. And then he had cold dinner and then grab tables and atmosphere. Now these were ranged from the highest to the lowest with a cumulative frequency. And then this is your cumulative frequency, which was taken by taking the total previous values, which is slow service, plus adding the cramp tables, and then giving a Pareto chart. So that's how a Pareto chart is constructed by taking the highest problem areas to the lowest, and that shows right away which are the problem areas that need to be addressed. So a quick review, we talked about process charts. We talked about how they can be used as a tool to analyze a process. We are right now talking about the tools to find out what are the problem areas in a process once a process has been charted out. So I will be signing off in a bit here and then beginning the second piece of this video, actually the second piece of this video in a moment here. Talk to you in a bit.